I guess look at what you made as comments versus what she has.
Double negative there. Plus or minus square root of b squared minus 4ac all over 2a. A lot of negatives to plug in here. Make sure you are using parentheses. This part's very tedious when you're using the quadratic formula. So just make sure you're taking your time. Double negative will give us a positive 12 here. Inside that square root, we'll end up getting 144 plus 12. This is where I saw some mistakes on the homework. They had it negative 12, but that negative 4 and negative 3 make it a positive. And this is over negative 6. We're going to keep on solving. So we have 12 plus or minus root 156 over negative 6. Jaden, what factors of 156 helped you simplify that square root?
I got 4 and 39.
Yeah. So we could split that root 156 up into root 4 times root 39. This gives us 12 plus or minus 2 root 39, because we take the square root of 4 there. Divide by negative 6. Anyone confused how we got here? Okay, so now we want to break it up. So we're making our two different fractions like that. So this is equal to 12 over negative 6 plus or minus 2 root 39 over negative 6 as well. Faith, what is 12 divided by negative 6 in front right here in the first part?
Negative 2.
Yeah. Then we have plus or minus. How can we simplify the second half of this answer? We have 2 root 39 over negative 6. Can we do something with that 2 and negative 6?
You can reduce it to 1/3.
Yeah. So then that will become 1/3. So we have root 39 over negative 3. And that negative 3, we know that plus or minus in front of it, that negative 3 won't matter because we're one time when we add it, it will be positive and the other time will be negative. So that's how we simplified here. So we know when we are finding our intercepts, then we are going to plug in our calculator. Negative 2 plus root 39 over 3, and then negative 2 minus root 39 over 3. And those will be our two intercepts. So go ahead and plug that in your calculator. And Jordan, tell me what you get once you plug those in your calculator.
I got 0.08 and negative 4.1.
Perfect. And I'm gonna write them as my intercepts on those lines. So that one was the tricky one with our x-intercepts there. Questions anywhere of how I solved there? All right, so now we have to graph. We have that axis of symmetry at negative 2. Vertex at negative 2, 13. That's not on our graph, but we know it's up there. Our y-intercept is 0, 1. And our x-intercepts are 0.08, which is right after that origin, and negative 4.1. So our x-intercepts are reflected over that x-axis. What other point can we reflect over that, or axis of symmetry, I mean? What other point can we reflect over that axis of symmetry to plot another point? Malachi.
0, 1.
Yeah. We can reflect that 0, 1 point over that axis of symmetry, which would land right there. And so now we can draw our parabola. And we can see it's opening down, which better be because our a is less than 0. Didn't ask for this, but we can see it also as a max. Questions on this problem? All right. So the next problem I also want to look at is this word problem at the bottom. So it says an online music store sells about 4,000 songs each day when it charges $1 per song. For each 5-cent increase in price, about 80 fewer songs per day are sold. Use the verbal model and a quadratic function to find how the store can maximize daily revenue. So they're already giving us our parts. We have our revenue, and they're giving us the parts for price times our sales to figure out what our revenue is. And so this step most people got. To get this function, to get this quadratic function, we're going to take those two binomials and FOIL. So I'm just going to rewrite it down below so it's closer for us. These are being multiplied together, and we're FOILing. So we have first, which would give us 4,000, outer, negative 80x, 0.05 times 4,000. What was that? Sorry. Oh, thank you. I forgot my x there. Then we have plus 200x. And last, we have minus 4x squared. 0.05 times negative 80 will give us negative 4. We can see we have two different x terms right there, which we can combine. And I'm going to just rewrite it as I'm doing this with the powers descending. So I'm going to put my greatest power first, which is that negative 4x squared. I'm going to combine that 200 and negative 80x, which is plus 120x. And then we still have that plus 4,000. So this is our quadratic function that represents how much their revenue. So they want us to find how the store can maximize their daily revenue. Well, we can see that our A here is negative 4. What does that tell us about this function if we were to graph it? Lacey, what does that negative 4, that A of negative 4 tell us about our function?
It would tell you that it'll be going down.
Yeah, it's going to open down. That negative 4 is less than 0, which means that this function looks like this. So Lacey, are we going to have a max or a min when we find that vertex?
Max.
Max. That vertex will be a max. So this revenue of this store is being represented by this quadratic. To get them to maximize their daily revenue, which is this function, we would need to find that vertex because we know it's the max that will maximize their daily revenue. So how do we find the vertex? Gabby Snyder, what should we do to find the vertex here?
Shouldn't you take negative b over 2a?
Yeah, we want to find that axis of symmetry. Negative b over 2a. So that's negative B, which is 120, over 2 times A, which is negative 4. So we have negative 120 divided by negative 8, which gives us 15. So that's our x coordinate. We also need to find out what our revenue would be. So we take that 15 and we're going to plug it in to our revenue function to figure out what that revenue is when x is 15. When you take 15 squared and then multiply that by negative 4 and continue to solve, you'll end up getting 4,900. So that means our vertex, which is our max, is 4,900. So let's think. So our x, so they're saying when we increase the song by 5 cents, then we will have about 80 fewer songs per day sold. So that x in our price function right here, you can see, is being multiplied that 0.05, 5 cents. So in order to determine how much they should increase their price, we need to plug that 15 into that price function, or part of the function, which is that 0.05 times x. We're going to forget about that 1 right now. So we're plugging 15 in, and we end up getting 0.75, and we're talking about price, so this is dollars. Valerio, what do you think this means? So what does finding that 0.75 cents mean?
It means that when you increase the price 75 cents, you'll have the maximum revenue at 4,900.
Exactly. So we need this music store to increase their price by 75 cents to increase their revenue to 4,900. And we're talking about daily revenue, so this is per day. So let's think about this again. We found that vertex, but then we need to apply it to the problem. They're saying our x is 15. X is being multiplied by 0.05. How many times are we going to increase the price of each song? So we're going to take our 15 and multiply it by how much? The increment of 5 cents. Questions on that? How we're applying that vertex. When we increase the song by 75 cents, then we will reach that maximum revenue of $4,900 per day. All right, if there's no questions, then we are going to continue onto notes and just look at 2 more real life application problems. So head over to page 32 of your notes right after where we ended yesterday. We're going to skip finding the calculator or finding the max and min on our calculator for right now. We will look at that later. We're going to go to example 5. So they're saying a go-kart track has about 380 racers per week, and charges each racer $35 to race. The owner estimates that there will be 20 more racers per week for every $1 reduction in the price per racer. How can the owner of the go-kart track maximize weekly revenue? So before, they gave us our function, but now we have to make it. So we know our revenue is price times how many racers we're going to have. So let's write this down. So how much we'll make will be determined by how many racers we have times the price. So they're saying a go-kart track has about 380 racers per week and charges each racer $35 to race. So that's the original, what they're charging right now. So for our price function, we have two different parts, price and racers. They already are charging $35 to race. So I'm gonna put that in my price part. And when we charge $35 to race, we get about 380 racers per week. So that's what they're already charging and how many racers they're getting. Then they're saying the owner estimates that there will be 20 more racers per week for every $1 reduction in the price. So they're saying that we would get 20 more racers. So on top of this 380 racers that they're getting, they're estimating 20 more per week. We'll put next there, but I'll explain. For every $1 reduction in the price. So if our price is being subtracted by $1 per week, then we will add 20 more racers. So that's both of those are being multiplied by X. So say we subtract our price per race to 34. So we have 35 minus 1, 34. Then we would add 20 more racers to our usual amount that we get. So that's why the second part, they're both being multiplied by X. That's what's changing, the price and the racers. So that's how he created that function.
Ms. Clark, can I ask a question real fast?
Of course.
So does the X just show that it's a different like group, or does the X stand for something?
So the X stands for what we are going to change the price by and how many more racers we'll get. So that's what we want to find. So we have this function, just like how in the last problem, we can choose whatever we want for the price, and that will determine how many racers we get, but we want to determine that maximum amount. So we are going to do that by multiplying that change in price and the change in racers by X. So
okay.
This is the starting amount. That's standard. We're not doing anything to that. That's what they already are charging and how many racers they're already getting. But it's changing. That can change by this other part that we're adding to both the price and the racers. It's going to determine both.
Okay, that makes more sense. Thank you.
You're welcome. And when we look at the next example too, hopefully it all comes together. Okay, so we have both parts of our function. Go ahead and FOIL. I'll give you a minute to go ahead and FOIL and get that quadratic function simplified. Once you FOIL, you should get this as your function. Now we can see that our A, just like in the last example, is less than 0. So we know our function is going to be opening downwards. So that vertex, that point, will give us our maximum, which is what we're finding. We want to find that maximum revenue that we can get. So we know we have to find the axis of symmetry and then find the Y value. I'll give you a minute to go ahead and do that. So you end up getting 8 for your axis of symmetry, x equals 8. And then we're going to plug that into our revenue. And when you do that, you would end up getting 14,160. So our vertex, that point, that maximum, is 8, 14,160. So what does that mean? Our x is what we are going to reduce the price by when we multiply it by 1. We're just subtracting. And then that also will determine how many more racers we get. So how can we explain what we should do to the price and what will be the outcome? What do we have to reduce the price by? Faith.
For the answer, I got 14,610.
You're right. I wrote it down wrong. Thank you.
Yep.
So this is our x and this is our y. We are subtracting the price right here by 1x. So how much do we have to reduce the price by? Helene, how much do we have to reduce the price by? What is our x and our vertex?
8.
8. And we need to reduce it by just 1 times that x. We're just reducing it by whatever our x is, right? That's what our price function says.
Mhm.
So we just need to reduce the price by $8. So we should reduce the price per racer by $8. And that's going to get us to that revenue. So that will increase. It's talking about per week. So the weekly revenue to 14,610. That's what Y is. Y is talking about our revenue. So determining on what the price is, you're going to get a certain amount of racers. So in order to reach maximum profit, we need to reduce the price per racer by $8 to get to that maximum revenue. And when we reduce the price, we end up getting more racers. We would get a bunch more racers when we reduce the price, which will end up getting the company more money. Questions on this one? All right, so now we're going to look at another one right below, and this is very similar. So here we're talking about a bicycle shop that sells about 18 bikes per week when it charges $100 per bike. For each increase of $10, the shop sells 3 less bikes per week. How much should the shop charge to maximize sales? So again, we're trying to find that maximum. We know that our revenue will be how many bikes we sell times the price. So again, we're going to make 2 different parts, one representing what's happening to the price and one representing what's happening to the bikes. So the bike shop, we are already selling 18 bikes per week with each bike costing $100. Is my sound cutting out? It's good. I got a chat saying that it is. Okay. All right. So what's already happening, what the price already is $100. We're already charging $100 per bike. And how many are we selling? We're selling 18. So we're taking what's already happening, what we're already selling it, and how many are being purchased, putting those into each price or the bikes, just like how we did last time. But then they're saying if we increase the price of $10, then we're going to sell 3 less bikes per week. So what should we add to the price part? Madison. So if they're saying if we increase the price of a bike by $10, what should we add to that 100?
Would you just add $10 to that?
Yeah, and what else has to follow it?
X.
Yeah, because we could increase the price by 20. We can increase it by 30. And Zach, what should we put after the bike? So they're saying if we increase that price by $10, then we're gonna sell 3 less bikes per week. So what should follow that 18?
Minus 3x.
Exactly. So think of it as 2 parts. First, determine what's already happening, and then what's happening to, if we increase, decrease, what's gonna happen then? And we just follow the same pattern. Go ahead and FOIL, get that function. Here's our function. We know we need to find that vertex, that maximum point on the graph that will help us maximize that revenue. Our x will be negative b over 2a. That will get us negative 2. When we plug that negative 2 in, we'll end up getting 1,920. So we know that that's the maximum profit we can get, 1,920 per week. So our vertex is -2, 1,920. So what does that -2 mean? We have a negative value. What does that mean we should do to our price? Jaden.
Does that mean you're gonna have to reduce it?
Yes, exactly. How much should we reduce it by? If it's being think about what it's being multiplied by.
Should it be $20 if you plug it in with that 10?
Exactly. So we should decrease the cost of a bike by $20 to increase or to maximize our revenue. To what we got as our outcome, that 1920. So it's the same steps that you're taking per problem on how to set it up. Questions on our explanation or any of the computations we did in that problem? Okay. So now we're gonna look at your homework for tonight. Your homework for tonight is just reviewing everything that we've done in section 4.1. So graphing, and there are a few word problems on here. So it is on Google Classroom for you, so go ahead and pull that up. There's graphing problems, word problems like we just did, and there's also an answer key as the last page. So I can start one of the word problems with you. I think we feel confident on graphing. So go ahead and pull that up. I'm going to start one of the word problems with you. So I'm going to look at number 6. So it says a store sells about 50 of a new model Blu-ray player each month at a price of $140 each. For each $10 decrease in price, about 5 more Blu-ray players are sold each month. And this is the same thing that we've been doing. We're going to do the price times how many Blu-ray players. So this is our price function. Here's what's happening to how many we're selling. So if we sell about 50 each month at a price of $140, our first function will represent our price, and our second one is how many we're selling, which is 50. That's what's already happening. And now what's happening if we change it? If we decrease the price by $10, then 5 more Blu-ray players are sold each month. Alyssa, what should we add to the price or subtract? What should change to that 140?
You should subtract 10x.
Exactly. And what about after the 50? What's happening to the number of Blu-ray players sold?
You would add 5x.
Yeah. Awesome. And then we know what to do from there. We FOIL, find the vertex, and they're asking questions about the revenue and what we should change. So I'll let you finish this one on your own. I wanted to set it up with you, just another example, same way of how we did it in class. So we have a few more minutes left in class. This is what your homework is for tonight. There is an answer key on the last page. Please make sure you are checking that. But feel free to hang around for a few minutes, start working on this. We can stay a few minutes after class if you have questions. Please don't hesitate to ask questions. This time is for you to review section 4.1 about graphing and these application problems, finding max and min. But you are free to go, but hang around if you have any questions. So have a great day and put any questions you have in that Google form.
Have a good day.
Thanks, you too.
Have a nice day.
Thanks, you too. Hi, Ava, do you have a question?
Yeah, I have a question about the 4.3 and 4.8 paper.
Yes.
On the review worksheet, is that what's posted in Google Classroom right now?
It should be. Yes.
Okay.
Can you see it?
Yeah, I can see it. So it's because I just want to make sure that wasn't like the retake of the test, or do I have to like schedule with you like one-on-one for the retake?
That worksheet is for you to do, and then you schedule the retake with us, right? Yeah. Then you will schedule the retake with us. So that worksheet practice before you do the retake.
Okay.
So Ava, you have to complete the review worksheet, which was emailed to you, and it's the same that's posted in Google Classroom. So you must complete that first. We're going to review it, look over it, give you comments on it, and then you can complete the retake quiz. Does that make sense?
Okay. Yeah, that makes sense. I just wanted to make sure I wasn't,